Welcome, everyone. You are at the talk, Let's Build an AI Security Research Team Using Python. My name is John Gillis. I am an automation engineer at Adobe, and I'm part of a team called ACDC, Rock On. That stands for Adobe Cyber Defense Center, one of the best departments ever. So, when we dive into this, I found that this was kind of really relative to what my experience was as I was building out this project and everything. A theory: when you know everything, but nothing works. Practice: when you know nothing, but everything works. Programming: nothing works, and we don't know why. And wrapping into that, in this day and age of programming, we use AI hopefully quite frequently to code. And I found this yesterday and I had to add it. I don't know if this is going to work. It should be really sad. Let's see really quick. Well, that's what I get for adding it at that point. I'll tweet it out after. Anyway, so when building an AI security research team, the term that I went for is to build AI agents. And this is the buzzword that we've all heard over and over and over. And people are starting their companies for billions of dollars. And the funny thing is, when you ask someone what is an AI agent, no one really knows. Oh, what are AI agents really? And this is, according to me, at this time and point of our very rapid growth in this area. But an AI agent is simply just a function. It receives input, and then it delivers output. Inside of this function, we can have things like we're using an LLM models. We can use GPT, we can use Llama, Sonnet, Minstrel, any of these. These LLMs can have access to a knowledge resource. We use vector databases for these right now. That might change. And they also have access to tools, which are functions, just sub-functions of the bigger function. And we'll talk about that in just a little bit. So what about frameworks to create these agents? We have CrewAI, AutoGen, LangChain, OpenAI Assistants, OpenAI Swarm, and the list just keeps on growing extensively. It's almost like if you're on X, you see a new AI framework every day. So there was a lot to choose from. We chose to try out CrewAI first. And what was the thing that we're trying to make? Well, it's that tier 1 SOC analyst work, that monotonous getting a detection, going and checking out and Google searches or VirusTotal or Shodan or any one of the hundreds of different tools that analysts use. The goal was to write a basic research or a report for the tier 2 analysts to consume easily. So our first attempt was with CrewAI. I didn't include all the code that went into that, but I ran into snags with CrewAI just to start off because the way that they create their agent communication system is by direct message. So for example, if you have a manager agent that's controlling a bunch of sub-agents, it would say, hey, I need you to write a VirusTotal report. And then the agent would say, oh, I can do that. Let me grab that. I'll make the report. And so when you run it in verbose, you basically would see this whole entire conversation happening. So the advantages there was it was easy to create a workflow. I mean, you got agents to do work, and if you fiddled around with it enough, you could get some good results. The disadvantages, though, was, first of all, it was slow. You're basically having these agents talk back and forth. It's almost as if you're looking at a mini department in your company trying to work together. And it's already frustrating to see that from a person in that department. It's even more frustrating when LLM agents trying to do it. And it's expensive. It can be expensive. So not only are we watching them communicate, we also pay for that communication. It's almost like you're the boss and you're watching your hours and your budget go down. I found that it was prone to hallucinating just because of the amount of talking that would go back and forth. I found that agents would get lost, loop themselves, make up junk. And I will be clear, that's probably because I wasn't doing it right at some point. I'm sure if you talk to the reps at CrewAI, they would do a magnificent job of showing you how it works. For me, I was like, no, I need to do something else. And I wanted to bring this up as you're working in AI, I think, or building these agents, the most frustrating thing is that it is changing all the time. Like I said before, there's a really popular place where you can publish your papers called arxiv.org. And so I just did a little experiment. I decided to search the term AI agent through the different years. So in 2022, I searched it and only got 8 results. Searched it again for 2023 and we got 37 results. Then I searched it again in 2024 and we got 122 results. And 2024 is not even over at this point. This is rapidly growing and changing. So I decided, hey, let's try this again. Let's roll it back and let's think about a different way of approaching this problem. So my initial thought was, what if we treated this like an assembly line and not as a group project? So right here was kind of the idea, and with most AI agent frameworks, this is how it's working. You have one manager AI or handler AI that's talking to a bunch of other sub AI agents that all have tools that they can work with. So instead, let's do this. Let's take our AI agents, let's give them very, very specific things to do, allow them to have the input, allow them to export the output, and let the other AI agent pick it up, work with it, and move it down the line. So over there in the corner, you can see I've added QR codes to the actual code right there. And I would love it if you went there, look at the code, and be able to follow along. You're going to be able to see all the prompts there. And hopefully, the code is clear enough to be able to understand. One of the first steps that's really difficult when you're creating a research team for this is, how does the information start? The information can start from a detection, it can be from a blog post, or anything that the tier 1 analyst is now ingesting and saying, okay, this is what I need to research. These are the important parts. And so that first agent, what it's supposed to do is it can take any detection and then be able to turn it into a JSON object. Very simple, very clear cut. There are features within the frameworks that I used, or OpenAI, that do this automatically. And it's a wonderful resource. So you can see here, we just got a simple detection. A file name, a file hash, an IP address, and then right there, a base64 encoded PowerShell command. And so in output is that an object. Step 1.5, because it kind of associated with the first one, is now this agent is looking at the JSON object, and I wrote in there a simple function to decode the base64. And the funny thing is, you don't need an LLM to do that. I mean, we have technology, it's amazing that it can already do that. And so wrote a function in Python just to decode that base 64. But then we get this nice command that was obfuscated before. Now we can take a prompt that says, hey, take this command line and break it down step by step. So now our JSON object of our detection is growing. We have more information. So with step 2, we now ask a new AI agent to take that detection that's been enriched and now create a step-by-step plan to research that detection. And so with this one, I used a more powerful GPT model. Now, it breaks each step down, and it tells you what the title of the step is, the description, the IOC type, and then it also gives you a tool. So when I was building these agents, I found that, and it's very, if you've worked with AI, the more context you can give it, the better the results you get. And so as I was building it, I found that tools, if I was able to give the name of the tool and already describe it along the path, there was less guesswork for what the next agent was supposed to do. And another point for giving this step-by-step, before I would throw the whole entire detection at it and say, hey, try to guess which tool you want to use to be able to figure out each individual part. And I found that my results were not consistent when that happened. The more precise that you can be with these agents, the more consistent it will be back. And to me, this makes sense. If you're working with people and you give them a project to do, or you give them a task that's wide open and you don't really explain what you want, your results may vary from that person. It's no different when you're working with these AI agents or these LLMs. So now in step 3, we're able to take the whole entire detection detection plan to research, and then iterate through each step. So step 1, what do I need to do? Takes it, looks through it, and is able to now run an agent that now has tools at its disposal. And those tools, we need to explain how tools now work with AI agents. The method that we currently have that works pretty well is called function calling. Function calling is when you write your own function, then you prepare a function schema or a design schema for the LLM to ingest. And so this example right here is from OpenAI. You can see that you give it the type, you give it the name, the description, you give the parameters that it passes. And these parameters are really the heart of this. It's the most important part about function calling. Because if you have a function that doesn't have parameters, you don't need to use an LLM for it. But when your function has parameters and those parameters can vary, then the LLM becomes really powerful, because now you can use your function in a variety of different ways. I've also heard that this is the most expensive way to call a function, which is absolutely true. So let's break this down. When you are using function calling, here are the steps you go through. First, your application calls the API or GPT, Llama, any of these, and it will take your prompt and define the functions. It will see the functions, and the LLM will figure out on its own if it needs to provide parameters in the function to solve your prompt or just to respond to your prompt. Next, To that part. The model decides whether or not to respond to the user or whether one or more functions should be called. Then on your side of your code, the API will respond with the specific function and the arguments to be used within that function. Then on your side, that function just runs, and then once it runs, the output is then provided back to the LLM. So then the LLM basically pretends like it ran the function and it gives the answer back. So when you see agents using these tools, none of these tools, as far as right now, are being run on the end of the LLM. They're being run on your own computer, and it's just intercepting the output and being able to translate the output back to the user. So the agent tools. Here are the simple ones that we started off with. So we use Showdown and VirusTotal just to check IP reputation, get geolocations, and do a VirusTotal report on hashes that we see. And you may ask, why would we use an LLM to call these functions? Wouldn't it be easier just to program it so that we automatically get these within the steps? And the answer there is, with LLMs and doing it this way, it becomes immensely more flexible in being able to get better results without writing tons and tons of code. I found that I can shorten down the amount of code that I'm writing and get similar results. And so the other thing about this is, as you're creating tools for an agent, you're able to scale them, if you were to imagine, vertically. If you imagine our assembly line that's coming through, we can scale horizontally by adding additional steps and additional agents, but then we can also improve vertically by focusing on a specific agent and giving it more tools or different functions that it can use. And so these were the simple tools, and then we went in and made a tool that was a little bit more crafty. So first, this tool called Advanced Search, it initiates a Google search for an advanced search, or if you guys have ever heard of Google Dorks. I gave the agent instruction to be able to craft its own advanced search. And so it passes this advanced search and it grabs the top 3 URLs, and then it uses a tool called Firecrawl, which is able to take any website and turn it into a markdown file. So I take those top 3 sites with the original query, and then we turn them into a markdown file, and then we submit a prompt that includes those pages with the query on top to Gemini, which I don't know if you guys have seen, but the Gemini models are significantly cheaper when it comes to the amount of tokens you want to use. The one model that I used for this allows you to use 1 million tokens for, I believe, 7 cents. And that's if you use under 124K tokens. If you go over 124K tokens in one of your prompts, then it costs 30 cents per 1 million tokens. 1 million tokens is about 750,000 words. And to give you context, the first Harry Potter is about 76,000 words. So it is a significantly cheaper model to use, especially when you have a ton of information and you just want to summarize it. So once step 3 has finished, and it's gone through each of those steps of the investigation plan that was created by the agent before it, then we go back to Gemini and we use the 1.5 Pro, which has a context window of 2 million tokens, and we stick the whole entire investigation log inside of one prompt, and then ask for it to summarize it. And from there, we're able to get the key findings. And so we can go from just a simple detection like this to this, where now it gives us more information about the PowerShell script, about the virus total detections, the domain that it found inside of the base64 encoded command, and also there at the bottom, it gives a smaller excerpt than I would want it to. I'd have to change it a little bit, but it also talks about the Google search or the search that it did on the file name. There's a lot of different potential avenues that you could take with this, depending on how your SOC works and what your processes and procedures are. This is infinitely changeable to what your needs are. And again, going back to the ability to scale horizontally or vertically is not difficult to do. As long as you make each agent do a very specific thing, that assembly line is easy to maintain. And so I was having a conversation with one of my good friends this morning, and he said, I wonder if in the future, he's like, I wonder if we're just going to start talking to people like we talk to our LLMs, which is, you now are an expert in XYZ with 20 plus years experience. Go do this. And my invitation to you guys is to get into AI agents right now. This is going to be something that is going to only grow, and building these functions that have capabilities like this are going to make your lives easier. So to all of you, you are now senior experts in AI agents. Go do it. All right, now I can take questions. That's it for right now.
Yeah.
Mm-hmm.
Okay. It's 19. They had made that the expert did verified that by.
Okay, so just to make sure I understood the question, did I have checks built into the code so that it would be able to tell me how well it's doing, basically? Perfect. That's a great question. So I didn't write any checks into my code doing that. What I did instead was I took this methodology of making the smallest, stupidest, plainest way of writing the code and then iterating over it over and over again as fast as I could until it got the result that I wanted. And so as I did that, I was the check at that point, and then I was able to get to a solution that came a lot faster and then put it in. Awesome. Good question. Yes.
You heard him.
Say that one more time.
Like,
So did I experiment with doing any refining training? Could you talk more about refining training, what you mean by that?
you bet. Next to come. You jerk.
So I guess kind of going, and I hope this answers your question, because it feels like it's similar to the first question. I didn't try, the refining training that I did was just through my own eyes at this point because it was a smaller project. And until I got to exactly what I wanted, I wouldn't move to the next step. If that makes sense. Yeah, go ahead.
And he did it. God.
Yeah, so the end code that I had at this point was delivering good enough I say good enough. The results were what I would expect a tier 1 analyst to give to a tier 2 at probably an 80 to 90% rate.
Really?
Yeah.
Pretty.
Yeah, that's a great question. So I hosted this on my laptop. I didn't push it out to any kind of cloud services at this point. What I did was I tried to modularize the code so that when you did push it out to a cloud instance, that you could look at using microservices with it. But I didn't take it that far. Yeah.
What like the yeah.
Yeah, so I can tell you over the course of doing this project for about 2 months, I think I spent $1.50. So if you're scared about cost in getting this, don't be. I mean, if you can't throw down $5, then we can talk. You have other problems at that point. But yeah.
I mean, there is any that are out there already. Gamers that are out. That's they.
That's a great question. I haven't. The only one I compared it to was CrewAI that I was working with. CrewAI and LangChain kind of follow the same strategy, which is like direct agent communication, where they talk back and forth. I haven't had a chance to see. So that brings up a good point. The reason that I changed to the JSON model like that is actually from X, because someone tweeted out or X'd out, I don't know how to say that, that it's much better just to use JSON output than conversation output. And that was like a huge paradigm shift for me. Oh, there we go.
So you said that this data you're getting back is at like a analyst level in a position. Does that mean that to get to like maybe a level 2 or a better kind of count, would you expect that another agent added to your assembly line, or just a more focused out plan that would maybe give you better answers on what you're putting in? So I guess a change in code to get a better answer, or would it be a change in like the LLI to get a better answer?
Yeah, that's a great question. So I'd say both. So one agent that I would love to see that I haven't built yet, but I'd love to do it, is an agent that has access to run scripts on an endpoint. And so I would probably see a tier 2 start doing that more than a tier 1. And so that would be one agent that would be by itself to be able to run these different commands on an endpoint. The other thing is, in your factory line, I would, on your vertical kind of on the first tier 1 analyst, I would start adding a bunch more tools to be able to do more research on that. So vertical and horizontal growth right there. Yes.
It's not one thing. The yep. Right. You're not compared to AI would not, or there other.
That is an excellent question. So my methodology when choosing an LLM is, when you're going through your first iteration of creating these things, use the best possible model that is available. And so within your budget. And so once you know a model works really well, that's when you start exploring maybe open source models like Llama, or different models that can be a lot cheaper to get your budget, a lot lower on how much you're spending. So start really big and intelligent and work your way down. So then you can measure your results against something that works well. Yeah. One more question. Yeah.
Like process. I cost read about, but look at that.
What was the AI you said? CrewAI.
think it's perfect. Like that. We have this simply line out.
That's a great question. CrewAI kind of burned me where I was like, I don't know if I could trust this, because when you're working in cybersecurity, we need things to be very direct and to work in a certain way. And it's kind of like a double-edged sword, because it takes time to figure that out, but then we also can write really direct code with it. And so when you're creating your AI agents, it actually makes it easier to figure out what it's going to do next. So with CrewAI, yeah, if you're running something that you don't really know what the output's going to be, and it's a little less consistent, maybe a first draft for your executive report on your IR. I don't know. That scares me. I probably wouldn't do that. Anyway. All right. Thank you guys, and have a wonderful day.